So now we're going to implement stacking in R. So remember, stacking is when we have a couple different or many different helper models and then a manager model. That manager model takes the original inputs together with those new predictions as its additional inputs and then learns how to blend those inputs to optimally predict the target. So conceptually, hopefully it makes sense. It's just a manager model deciding how to blend predictions. But how do we do this thing? Like there's like a kind of a leap between the conceptual idea and the implementation in R that we need to tackle here. So let's do that. So the first thing we need to do is, and I'll put this in so tabbed a little bit, so or indented. So let's do make full predictions. So what the model is ultimately going to need is an augmented data frame. And so it needs to have these helper model predictions for the entire data frame. Like we need new columns that are the helper model predictions. So we're going to do something that we've never done before in the course and we will never do again, and that is predict on something than just test. So I want to say like this, pred, and we're going to use the random forest and the boost as our helper models because they're already sitting around. So we'll say pred boost full equals predict. And I'll do, I have to be so clear about these things. Let's do them in order. So we'll say predict model, and see how I do that. I can't help myself. Predict model, and it's not model, gosh. Predict, we called our model RF, and we predict, we're not predicting on RF, or not on test, we're predicting on DF. So sorry, that was kind of ham-fisted. Let me go through the whole thing again. We're trying to make predictions for the entire data frame, and that's because if the new model, the stacked model, is going to use this as an input, it needs it for all of the entire data frame. It's like we're making a whole new column for the whole data frame. And so when we're predicting here, we're going to predict from our random forest on the whole data frame. And so when I do this, for instance, I get a new variable that is 506 entries long, which is the same as my data frame. The same as my data frame. So I have one prediction for every single row in the data frame, training and test. I need the whole thing. This is like a whole new column I'm going to put on the data frame. And then similarly, I'll say pred boost full is predict boost df, and then I need two other things, right? I need best size and type equals response. There we go. Both of these cases now I have numerical probabilities for pred RF full and pred boost full. These are my actual probabilities. Now there's an open question about whether, like when I feed in the new predictions into as a new columns in my data set, should those be trues and falses? Should those be numbers? I tend to err on the side of numbers because the model can always learn to apply its own cutoff probability, essentially, and that may be a little unclear. But by giving the numbers, you're giving the rather than the trues and falses as our predictions here. So we could do trues and falses, or we could do the numerical probabilities. By giving the probabilities, you're allowing the model more latitude. You're giving it more detailed information, and that seems like a good thing. Although you should always just see how it goes. So we want df stacked. This is going to be our new data frame that's going to build, we're going to feed into our stacked model. Here's a new command. We want to do a cbind, which is binding columns onto the data set, and it's going to be the following thing. We want to do df pred RF full and pred boost full. So what is this going to do? It's going to take the original data frame, it's going to slap these on as new columns, cbind, bind columns. There's also an rbind, which binds rows that you might want to use at some point. So notice what happens. The original data frame had 13 variables. This new stacked data frame that we're going to use for our stacked model has 15. The original 13, the predictions from the random forest, and the predictions from the boost. So we have all of these different pieces all together. So now we need to repartition, and this is critical. So we'll do training stacked equals df stacked, and here's the critical piece. We use the same training cases that we already used. We've already partitioned up here, and to make sure all these comparisons are accurate, I need to expose the stacked model to exactly the same rows that I did the random forest and I did the boost. This also prevents leakage in a pretty subtle way. But if you're repartitioning, you're basically mixing up information from training and test between the predictions from the helper models and the stacked models. Like you're actually mixing training and test together. If you don't make sure that the training cases are the same for every single model involved in your data set. And the way to do that in this particular case, because everything's in one file, is just to not resample. Notice we're not running this sample line again. Like these are not happening. We're using the same training cases and not regenerating. This means that the rows that the stacked model sees for its training data set will be exactly the same row numbers that the random forest saw and that the boost saw. So we can do the same thing for test. Test stacked equals df stacked and then minus training cases. Training cases. Oh, and I hate that I have camel case. This is called camel case when we have this upper lower thing, and then I have underscores. Sloppy. What am I turning into? All right, so here we go. So notice that test stacked is the same. It has 202 observations instead of 13 variables. It has 15. But if I were to look through these rows, they are the same exact rows, except that test stacked has 2 additional columns tacked on the end: the predictions from the random forest and the predictions for the boost. So now that we've done this, everything proceeds exactly the same. So you need to decide, for instance, what type of stacked model do you want to use? That's entirely up to you. What type of overfitting protection do you want to use? Like all of this stuff. So just for fun here, we're going to do GLM, make a logistic regression model. Is high val as a function of everything. Data is coming from training, not just training though, stacked. And family equals binomial, just to make sure that everything's good. This is yet another reason that we used a logical target to make sure that we could use a logistic regression here at the end. This can happen, so this warning is happening because we have some really good predictors. Like if we're feeding in these predictions from the random forest and the boost, they're really good predictors already. And it's basically saying like something's going on. You have some columns in here that are really tightly correlated with the target. Is this okay? And in this case, it's like, yeah, well, that's kind of the idea. So let's say pred stacked equals predict. And what do we want to predict on? We want to predict using stacked, and we want to predict on test stacked. If you put test, you'll get an error because we're not. It's looking for those RF predictions and those boost predictions, and we want the type here to be equal to response. Let's see what we get here. For some training test partitions, you can get some strange results. And so here is one of the things. So what am I doing? Pred stacked. So see what it was saying. Some of these predictions are actually legitimately 1, and some of these predictions are actually legitimately 0. So it's like the model is very, very sure of some of these things. So this is the concern. So if we say then pred stacked, just so we can compare all of these things together, we'll say greater than 0.5, and then we'll say error stacked equals exactly the same thing. Actually, that's fine. Pred stacked not equal to observations divided by the number of rows in test. So what do we see here if we run this thing? In this particular case, we get error stacked is 1. So what did I do wrong here? That's very surprising because it means every single prediction was exactly wrong, and typically that is not the case. So typically what that means, do you see it? I forgot to run pred stack, this line here, 47. I wrote it but forgot to run it. So let me run through my logic here again. If I see an error rate of 1, that can't be right. But I'm laughing because it's like it's so wrong it can't be wrong. You know, like there's no way you got 100% of your predictions wrong. And in fact, if you could, like say you could go to Vegas and you know, on a roulette table, it's either black or red, and imagine you could exactly get those wrong every single time. Then you can get it right every single time by just guessing the opposite of whatever your prediction is. If you get it wrong every time, you just reverse your prediction and you're right every time, right? So this cannot be correct. It just can't be. And the reason, the way I know this, I go through here and then, look, my pred stacked are still numbers. And so this is problematic. It means that I just did not run line 47. When I do run line 47, everything's okay. And now I can actually compute my error stacked and get 18. So in this particular case, this problem, the stacking did not help. It actually made it worse. Like it did not learn its way out of the problem. This can for sure happen. And it may mean, for instance, that GLM is not the right, like a logistic regression is not the right blender. You might say something instead like, well, we don't have R part loaded, but you could experiment with different model types. It might just say the logistic regression is not the right thing. It also may not always be true. Like if we run this thing again, for instance, in this case, the stacked is better than the other ones. It's the best among all of them. And so, it's one, I have two, maxims for making these videos. One is if I have an error like that, the error rate 1, like I'm not going to shy away from it. We just need to debug it together. The other one is sometimes models don't work well, and we have to see that too. It is not always the case that stacked is going to do better than everything else. You have to see, like at this point in our data science journey, we have to recognize that so much of what we do in actual machine learning in practice is experiment. You build intuition over time. There's no two ways about that, about what's going to work better and what's going to work worse. But there's no kind of substitute for just getting in there and seeing what works and what doesn't. You have to be careful. We don't want to be, using this test over and over and over again to make decisions about which helper models are good and which helper models are bad. We have to be careful about leakage and overfitting and all of these things. But properly done, there's nothing that replaces just getting in there and experimenting. So see what happens. Try different things. See if you add some other helper models, does this number get driven down? If you can use a different manager model, if you do some feature engineering, is it true for all training and test partitions? Who knows? You really have to get in there and just give it a shot. So happy hunting.